Here I'm on question 1A, and we're supposed to explain why sodium ion has a smaller radius than a neutral sodium. In this case, I'll draw the picture. What's important? It is important to know how many protons are in the nucleus because they pull on the electrons. There's no difference in the nucleus. 11 protons for each. 2 electrons in the first shell, no difference. 8 electrons in the second shell, no difference from these two pictures. But what is different is this third shell of 1 electron is not here. So you can see just from the picture, this is a smaller radius. And the explanation would be Na plus has 2 shells, while Na neutral has 3. Period. So that's a simple explanation. Now looking at 1B, aluminum ion, smaller radius than magnesium ion. So this is a different reason than before. If we say, what does aluminum ion look like? Draw a picture. 13 protons for aluminum ion. How many shells? Well, 2 electrons in the first shell and 8 electrons in the second shell. And normally there would be 3 electrons out here in the third shell if it were aluminum neutral. So there would be 13 pluses and 13 minuses. But aluminum plus 3 doesn't have those 3 electrons in the third shell. So I'm taking my eraser and I'm getting rid of that third shell. It doesn't exist. So that's aluminum plus 3. And now we'll compare it to magnesium plus 2. What's in magnesium plus 2? Well, it's 12 protons. Its atomic number is 12. 2 electrons in the first shell. 8 electrons in the second shell. Once again, normally would have 2 electrons in the third shell if it were neutral, but it's the ion, so this is it. We're done. Mg2 plus. Which one's bigger, or are they the same? Well, the number of protons in the nucleus determines the size of the shells. The aluminum has more protons, more pull, so the explanation will be greater attraction from 13 protons pulls the electron shells closer. Let me write it exactly the way I said it. Electron shells closer to nucleus. That's a smaller radius. Boom.